Every evening, we see the sky slowly turning red, orange, and pink. But have you ever stopped to wonder why it is that the sky turns these colors at sunset and sunrise? In this video, we'll explore the science behind this beautiful natural phenomenon and learn why sunsets can be so captivating. Let's get started. During the day, when the sun is high in the sky, its light comes to our eyes in a relatively straight line. Because the sun is so far away, we perceive its light as being almost everywhere the same color, white. However, as the sun begins its descent toward the horizon, its light has to travel a much longer distance through the Earth's atmosphere to reach our eyes. As a result, the light undergoes a process known as scattering, where it is dispersed into different wavelengths or colors. Due to interactions with the molecules in the atmosphere, you see, the atmosphere is made up of several layers, each with different properties. But for this explanation, we will focus on the lowest layer, the troposphere, which extends from the Earth's surface up to about 7 to 15 kilometers above sea level. The troposphere contains a variety of molecules such as nitrogen, oxygen, water vapor, and aerosols. These molecules are much smaller than the wavelengths of visible light. When sunlight enters the troposphere, it collides with these molecules, causing them to vibrate, and the light gets scattered in different directions. Now let's talk about the different wavelengths of light. Visible light has wavelengths ranging from about 380 to 750 nanometers. Shorter wavelengths like blue and violet scatter more easily than longer wavelengths like red and orange. This phenomenon is known as Rayleigh scattering after the British physicist Lord Rayleigh, who first described it in 1871. According to Raleigh's law, the intensity of scattered light is inversely proportional to the fourth power of the wavelength. In simpler terms, shorter wavelengths are scattered more easily than longer wavelengths. So what does this mean for our beautiful sunsets? As the sun approaches the horizon, its light has to pass through a much thicker layer of the atmosphere than when it was higher in the sky. Because of this, the shorter wavelengths of light, blue and violet, scatter out in all directions, leaving the longer wavelengths, red and orange, to dominate. This is why we see these colors in the sky at sunset and sunrise. But there's another important factor to consider: the angle of the light. When the sun is low on the horizon, the light rays enter the atmosphere at a shallow angle. This means that the light is less likely to be scattered back toward the observer, resulting in a more intense display of colors. Additionally, the longer path through the atmosphere means that some of the blue light gets scattered so much that it no longer reaches our eyes. This leaves behind a sky dominated by the warm colors of red and orange, creating those stunning hues we all know and love. It's also worth noting that the presence of clouds, aerosols, and water vapor in the atmosphere can affect the intensity and distribution of these colors. For example, high-altitude cirrus clouds can reflect and amplify the colors, creating a more vivid display. So the next time you witness a beautiful sunset, take a moment to appreciate the fascinating interplay of light and atmosphere that creates this breathtaking spectacle. Remember that you're witnessing a beautiful interaction between light and the atmosphere. And if you want to learn more about our amazing planet and the universe beyond, don't forget to stay tuned for more videos. Until next time, keep looking up and stay curious. We've reached the end of our video. If you found it interesting and informative, please give it a thumbs up and share it with your friends. And if you haven't already, please subscribe to our channel to keep learning more about our amazing planet and the universe beyond. Thanks for watching, and we'll see you in the next video.